Okay, these are the solutions now from the practice test that we started today, but we ran out of time to go over. So if you're okay with the problems we went over already, just fast forward, but I know we went a little fast, so if you didn't understand, I'm starting from the beginning. Okay, so here's question number 1, and we're looking for points of inflection, so that will be the second derivative. Okay, we're going to set that equal to 0. Factor out a 20x squared. We're going to get two solutions, x equals 0 and x equals 3. So they're only points of inflection if there was a sign change. So we have to make a wiggle graph. And we're going to use y double prime, which is right here. Okay, so if we try y double prime of -1, we're going to get 60 times 1 minus 20 times -1. So 60 plus 20 is positive. And if we do y double prime of 1, we're going to get 60 minus 20, that's positive. And then y double prime of 4 will be 60 times 16 minus 20 times 64. So, what will this be? 960 minus 1280. So this is negative. Okay, so we are looking for points of inflection, and points of inflection only happen when the second derivative is set equal to 0 and has a sign change. And so here at x equals 0, there was no sign change, so that's not a point of inflection. So there's a point of inflection at x equals 3, and that was choice C. Okay, question 2. This was the original function. And we're looking for increasing and decreasing, so that involves the first derivative. Set it equal to 0. Okay, and this will make no sense because if you take the square root of both sides, we can't take the square root of a negative number. That means that there are no critical points, and so to find out if it's increasing or decreasing, we're going to make a wiggle graph. The first derivative always tells us about increasing and decreasing, and we can just choose any number we want. So 0 is typically the easiest number to use, and if you put 0 in there, you're going to get a positive value. That means that the function is always increasing. So that was choice C again. Okay, question number 3. This was the original function. And we're looking for concave down. So before anything, so we don't screw this up again, this function is undefined when x equals 2. So we're just going to put x equals 2 on hold over here because we know bad things happen at x equals 2. Okay, so for concavity, it's the second derivative. And so in class we talked about that this would be easier if we rewrote it like that. So the first derivative is going to be a power rule, -1 times, a chain rule, -1 times -5 is a positive 5. Keep the inside, -1 minus 1 is -2. But we need the second derivative, so we're going to get -10, it's chain rule again, to the -3. And if we rewrite that without the negative exponent, it's going to look like, just make a line here, it's going to look like that. Okay, so the second derivative, set it equal to 0, cross multiply, we get -10 equals 0. We know that's not true, so that means that there are no points of inflection, but we need to see if it's concave up or concave down. So we're going to make our wiggle graph. So remember, that's for the second derivative, and the only number that we know is a problem is 2. So let's put 2 on there. So this is our second derivative. I'm just going to make some room here. And I'm going to rewrite our second derivative a little nicer. So it's negative 10 over x minus 2 to the third power. Okay, so if we do y double prime of, let's try 0, we get negative 10 over a negative 2 cubed, which is negative 10 over negative 8, so that's positive. And if we do y double prime of 3, we're going to get negative 10 over 1 cubed, which is just 1, and that will be negative. And so the question is asking, when is this concave down? So it's concave down from 2 to infinity, so greater than 2, and that is choice E. Okay, question 4. We're given the derivative. And we're looking for increasing and decreasing. So we could immediately just set that equal to 0. Bring the negative term to the other side. Cross multiply. And we get x cubed equals 2. So if you take the cube root of both sides, you will get x equals the cube root of 2. Okay, we're going to make a wiggle graph. And for increasing, decreasing, that's the first derivative. So we did speak in class about how do you know, like, what values are to the left and the right of this. So what number multiplied by itself 3 times will give you 2? So obviously, if you choose 1, it's just going to give you 1. If you choose 2, it's going to give you 8. So it's got to be a number between bigger than 1 but smaller than 8. So we know that we could definitely try 1 as a value. So y prime of 1 is going to be 1 minus 2, which is negative. And then if I want to choose 8, I could do y prime of 8 equals 64 minus 2 over 8. So that will be positive. Okay, let's go back to the question, which says, when is it decreasing? So it's decreasing from negative infinity until it gets to the cube root of 2. Okay, so if you look at the choices, it looks like D is going to be the answer, and what mistake did we make? We didn't see that when x equals 0, there's an issue. So we're going to have to revamp our wiggle graph. So we should have had 0 on there, and then we'll put cube root of 2. Oh, I don't need another one, just those two. Okay. So we'll just redo this, not a big deal. Good practice anyway for you guys. Okay, so always be careful when there's a fraction. So if we do y prime of negative 1, we're going to get 1 minus 2 over negative 1. That gives us 1 plus 2, so that's positive. And now we're back to where we were before, and I even forgot what we got. So y prime of 1 is just going to be 1 minus 2, so this is negative. And then y prime of 8 will be 64 minus 2 over 8, so that's positive. Okay, so the question is, when is this function decreasing? It is decreasing from 0 to the cube root of 2, and that is choice D. Okay, this is number 5, and for number 5, we need to just find about increasing or decreasing. So first we'll find the derivative. Set that equal to 0. Factor out a 3x. We get x equals 0 and x equals 1. Make a wiggle graph. And we're going to be plugging into the first derivative because we're interested in increasing and decreasing. Okay, so y prime of -1 is going to be 3 plus 3. So that doesn't give us a sign, so we're going to have to try another value. So we'll do -2. And we get 3 times 4 plus 6, so that's going to be positive. And then we'll try y prime of 1/2, and that will give us 3 times 1/4 minus 3/2. So that gives us 3/4 minus 3/2. So 3/4 minus 1/2 will be a negative. And then we can try y prime of 2. That will give us 3 times 4 minus 6. 12 minus 6 is positive. Okay, so we go back to the question, and we're being asked when is it increasing or decreasing. So it's increasing from -infinity to 0 and from 1 to infinity, and then it's decreasing from 0 to 1. That's number 5. Okay, number 6. Okay, it's about concavity, so we need the second derivative. Okay, so that's our second derivative, and we're going to set that equal to 0. Factor out a 30x. I'm going to go over here. So we're going to get x equals 0, and then we're going to have 2x squared equals 1, so x squared equals 1/2, so x equals plus or minus the square root of 1/2. Okay, let's make some room up here. Okay, so the question is about concavity, so we're going to put all these values on here. So we had 0, we have 1 over radical 2, because the square root of 1 is just 1 anyway, and then -1 over radical 2. And we're going to plug into the first derivative, because that the second derivative, sorry, that tells us about concavity. That was this one, right? Yeah. Okay, so let's do y double prime of -2. We'll get 60 times -8 plus 60. So -480 plus 60, that's going to be negative. Okay, so I think this is what Annette was talking about. If you don't have a calculator, how do you even know a number between 0 and 1 over radical 2? Well, 1 over radical 2 has to be equal to like 1.2 something. So you're really talking about 1 over, let's just say like a 1.2. So I think it would be safe, like if we did a -1/10, for example. So, okay, so I'm going to try y double prime of, let's say, -1/10. So I get this when I substitute in. Okay, so what do I get? 60 times -1 over 1,000 plus 30 over 10. Okay, I'm going to go to this little box up here. God, this is crazy. So -60 over 1,000 plus 3. So this is going to be positive. That's what we care about. Okay, let's try another value. All right, so why don't we do a positive 1/10 this time? and we're going to get 60 times 1/10 to the third minus 30 times 1/10. This is going to be 60 times 1 over 1,000 minus 30 over 10. So we get 60 over 1,000 minus 3. So that's going to be negative. Thank God, there's only one more to do. And let's do y double prime of 2. And we get 60 times 8 minus 60. So 480 minus 60 is positive. So the question is asking, when is this concave up? So it's concave up from negative 1 over radical 2 to 0, and then from 1 over radical 2 to infinity. Okay, last problem. This is number 7. And we have this. We have to do everything. Okay. So first we'll do the derivative. Set that equal to 0. We could factor out an x squared. We're going to get two answers here. We're going to get x equals 0 and 4x equals 9, so x equals 9 over 4. Okay, so we needed critical points, so our critical points are x equals 0 and x equals 9 over 4. Okay, next we needed to know about max and mins and increasing and decreasing. So I could do a wiggle graph with a second derivative test, but since I also have to do intervals of increasing and decreasing, I may as well just do the wiggle graph. So I have 0 and 9/4, which is what? 2 1/4. So let's just keep that in mind. Here's my y prime. So y prime of negative 1 will be 4 times negative 1 minus 9, which is negative 4 minus 9, so it's negative. Okay, then we'll have y prime of 1, which will just be 4 minus 9, so that's negative. And then we'll do y prime of 3. That will give us 4 times 27 minus 9 times 9, which is 108 minus 81, so that's positive. Okay, so the next part of the question was max and mins. Okay, so there's a sign change here at 9/4, so it went from decreasing to increasing. So I can say there is a min at x equals 9 over 4. And over here at 0 there was no sign change, so it just means that the slope is 0 there, no max or min. Okay, intervals of increasing and decreasing. So it's increasing from 9 over 4 to infinity, and it's decreasing from negative infinity until it gets to 9/4. Okay, let's make some room. Now we're going to go into the second derivative. Okay, so here's the second one. I'm going to set that equal to 0. We can factor out a 6x. And we're going to get x equals 0 and x equals 3 over 2. So let's make our wiggle graph. So 3 over 2 is just 1.5. So this is the second derivative. So we're going to do the second derivative with negative 1. Here's the second derivative right here. So we're going to get 12 plus 18, so that's positive. Then we'll do the second derivative of 1, which gives us 12 minus 18, which is negative. And we'll do the second derivative with 2. 2 squared is 4. 4 times 12 is 48 minus 36, so that's going to be positive. Okay, so we need points of inflection, so you can see that There are sign changes here and here. Okay, so we can say that there are points of inflection at x equals 0 and x equals 3/2. And then we can say we have to find concavity, that it's concave up from negative infinity to 0 and then from 3/2 to infinity. And we can say it's concave down from 0 to 3/2. Okay, and that finishes the practice test.